We're going to be working through 8.2, but really quick I want to look back at 8.1 and just remind you we've been working with factoring the greatest common factor, which is kind of like reverse distribution. So if I have, these are from the notes from 8.1, but if I'm given two terms, I'm going to look for my greatest common factor between my numbers, which is a 2, and my greatest common factor between my variables, which is an x to the first power. And I'm going to divide that out and be left with 2x times 1x to the first plus 3. When we divide that out, we're doing reverse distribution. So it's kind of like with regular distribution, if we were given a problem just like this, we would multiply it in to create 2x squared plus 6x. So taking the greatest common factor out is like doing the reverse of that. We're pulling a common factor, a common number that multiplies or that both of these terms share, and we're pulling that out and we're saying what's left over. And so we've been working with building fluency on these, where we divide out the common numbers. So between 14 and 49, there's a 7 in common that we can divide out, and we're left with 2x to the third plus 7. Jumping to what we're going to be working on today in 8.2, we're going to be doing something similar, but we're going to start learning, there's a special pattern that exists, and we're going to learn how it works within a trinomial. So a trinomial is a polynomial with 3 terms. And our trinomials are made up of 2 binomials that multiply together. So hang with me here. Think about how we've been working with reversing, like let's say I had 2 times x plus 3. And so we worked on distribution, right? So we have 2x plus 6 here. And essentially, greatest common factor was taking this and getting it back to what we had. Today we're going to learn about, or we're going to begin learning about, like what if we have x plus 2 times x plus 7? And for these are the double distributions. So x times x gives us x squared, and x times 7 gives us 7x. And 2 times x gives us 2x, and 2 times 7 gives us 14. And then we combine our like terms, and we have x squared plus 9x plus 14. So here's our trinomial. So when we multiply 2 terms times 2 terms, it gives us a 3-term answer, or what we call a trinomial. So we are going to begin learning the steps of how to take a trinomial and get it back to what it started as. The same way that with greatest common factor, we learned the steps to take a binomial and get it back to what it started as. And there's a special pattern that's taking place. So we're going to see 2 different kinds of trinomials, but today we're just going to focus on one, and we're not even really going to work on breaking it down. We're just going to start learning the pattern first. So standard form is there's a number times x squared plus a number times x plus a number by itself. And these could be plus or minus. So an example would be 1x squared plus 5x plus 6. And there's no leading coefficient, so leading would be like, it's really just if a equals 1. So our first term here has a 1. So we could say a equals 1 would be the other way to look at that. A leading coefficient, which we're not going to see for quite a while, but notice that our a is greater than 1. It's going to be any number larger than 1, or just any number that's not 1. So in this case, we have a 2 here. So a does not equal 1. A is a different number other than 1. And there's a different set of rules that we're going to learn for that. Some similarities, but we're going to focus on no leading coefficient. And essentially what we're going to do to figure out, because this could be turned into two groups of numbers that multiplied to make it. And with no leading coefficient, they're both going to have x's. And so we have to figure out, well, what numbers belong here that would multiply to make 6 and combine to make 5. And so there is a way of organizing our work called the x factor that we are going to start using. In today's lesson, we're just going to practice filling out the x factor for very simple numbers. So for this one, for this example, in our x factor, what we're going to do is we're going to take our last number, and that goes up top. So I'm going to put a 6 up here. And I'm looking for what would multiply to make our last number. And then for our middle number, our b term, right? So this is b, and then this is our c term. So our c term goes on top, and our b term goes on the bottom, and it's a positive 5. So I want to use the signs that are attached to these numbers. So it's a positive 5, and I want to know what adds or subtracts to make 5. So the x factor, this is a way of organizing our work. We want to know what will multiply to make 6 and add to make 5. So off to the side here, I'm going to list the numbers that multiply to make 6. So 1 times 6 and 2 times 5. And now that I have my factors, if I look this way, 1 plus 6 makes 7. So that's one possible combination. Oh, I'm sorry, 2 and 5. 2 times 3 makes 6. I don't know why I wrote a 5 here. So then 2 plus 3, I think I was thinking of the answer, makes 5. Okay, so this is 1 like plus 6 equals 7, and 2 plus 3 equals 5. There's two other options here, which is to subtract. So think about this. If I go from right to left and subtract, I would have 6 minus 1, which would be 5, and 3 minus 2, which would be 1. And I have a whole little chart full of these, but we're not going to use it yet. You're going to practice doing this without the chart first, okay? And then I may be giving you the chart. And so there are two options of what could make 5. But in order to create a 5 here, we need a positive 5 and a positive 6. And 6 minus 1 would make 5. So if I used a 6 and a negative 1, these multiply to make a negative 6. So that's no good. So these ones don't work. And sometimes there's only one option, and they're really easy. Sometimes you get two options and you have to figure out. So this one didn't work here. So 2 and 3 make 5. So 2 times 3 makes 6, and 2 plus 3 makes 5. So these are little number puzzles. So I'm going to fill out the x factor. When we have a trinomial, let me go back to my example here. So when we find 2 and 3, these are the numbers that are used that multiply up. If I were to multiply this out, I would get back to my original. And we're not going to work on making this today. We're just going to work on filling out our x factor. So I'm just going to use these numbers to guide, but really we're going to focus on the x factor because you're just going to be given an x like this in delta math, and then you're going to figure out what numbers work. So if I have 24 on top, I'm looking for what will add to 24 or multiply to 24 and combine to make 11. So I'm going to list my factors of 24. So in 24, we have 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, and 6 works, but we've already listed it with 6 times 4, 4 times 6. So I'm going to look from left to right. I'm going to say, could 1 and 24 make 11? No, because that would either make 25 or 23 if I subtract. Can 2 and 12 make 11? This would make 14 or 10. So that one's no good. Can 3 and 8 make 11? 3 plus 8 is 11, and 8 minus 3 is 5. So that's no good, but here's an 11. And then let's check our last one. 4 and 6 could make 10 or 2. So those are no good. So 3 and 8 are my magic numbers. 3 and 8 multiply to make 24 and add to make 11. So those are my two side numbers. Let's see another example here. 54. So in my big X, I'm going to have 54 on top. I'm looking for what will multiply to make 54. 15 on the bottom, what will add to make 15. So I'm going to list my factors. So if I'm thinking of 54, I have 1 times 54. And then you could divide. You could say 54 divided by 2. And if you get a decimal, it doesn't work. If you get a whole number, it does work. So for this one in your calculator, if you did 54 divided by 2, you're going to get 27. And then if you do 54 divided by 3, you're going to get 18. And if you did 54 divided by 4, you'll get a decimal. 54 divided by 5, you'll get a decimal. 54 divided by 6, you'll get a 9. 54 divided by 7 won't work, or by 8 doesn't work, and then 9 we've already listed here. So we've listed all of the factors of 54. And now we're going to see which ones could make 15. And if you're good with your factors or your multiplying numbers, you may not need to write these out. So those aren't going to get us close to 15. These aren't going to get us close to 15. 3 and 18, if I do 18 minus 3, that does make 15. But one of them will have to be negative. And 6 and 9 also will make 15 if I add them up. And that'll make a positive. So let's see here. If I used 3 and 18, the 3 would have to be negative and the 18 would have to be positive in order to get to this 15. But a negative times a positive gives us a negative answer, so those don't work. So the 15 that we get from 3 and 18 doesn't work. What about 6 and 9? So 6 times 9 makes positive 54, and 6 plus 9 makes positive 15. So 6 and 9 are the magic numbers that we need. So for today's lesson, that's what we're going to be working on. I'm not even going to go any further. We'll come back to these notes pages in future lessons, like 8.2.2 and so on and so forth, and we'll start practicing. But today we're just going to be filling out that X factor.